사회자 쪽 불 켜주실래요? 다른 말은 모르겠는데 이거 하나는 들리네요. 욜로. 전현우 씨의 욜로 하는 발표 한번 들어보겠습니다.
큰 박수 부탁드립니다.
Many services use object detection. Autonomous driving and security cam are examples of autonomous object detection technology. So, what is object detection? To answer this question, we need to talk about RCNN technology. Regions-based convolutional neural network is an expanded model of CNN algorithm. The CNN algorithm extracts the characteristic of image data and sort out the image into defined classes. For this reason, it cannot find multiple objects in image data. RCNN is the solution of this problem. RCNN has two models. The first model is region proportional model, which finds the location of object in image data. The region proportional model scans the whole image and finds the object bounding box. For this reason, object detection can find multiple objects in image data. After the innovation of RCNN, we could find multiple objects in image data. However, RCNN has one shortcoming. RCNN is too slow. You probably know YOLO as having different meaning, but in artificial intelligence, it is the object detection model. YOLO stands for you only look once. As the name suggests, it is the algorithm that performs object detection by viewing images only once. Let's talk about basic structure of YOLO algorithm. Before the input data, YOLO divide the image into divide the classes. When you put the processed image into YOLO algorithm, we can get bounding box and class property data. Finally, it creates the bounding box and class on image. YOLO algorithm is faster than RCNN algorithm because it uses a single model and scans images only simultaneously. Let's compare fast RCNN and YOLO algorithm. Before we compare this algorithm, we need to know about this. The MAP value means the accuracy of object detection model, and FPS implies the number of objects that object detection model can detect per second. Simply, it is the speed of object detection model. The MAP value of fast RCNN is 70%. It is 6.6 percentage point higher than YOLO algorithm. But YOLO has 45 FPS, which is 90 times greater than fast RCNN. For this reason, we can detect objects not only on images, but also on videos. But we have some problems. Image and video has huge differences. When things move fast, the appearances of object is unclear. If the camera is located outside, it can be easily disrupted by moisture, dust, and other things. The interference of humidity and dust can affect the quality of data. The image, especially provided by dataset, is clear and easily recognizable. Yolo V7 used these images to train the model. For this reason, object detection model should be trained by images that contain characteristics of video data. Motion blur image and Gaussian blur image occur in very extreme conditions. So I used data augmentation technology. Data augmentation is the technology that generates new data based on previous data set. Data augmentation has various techniques. Mirroring, random cropping, rotation, and local wrapping are examples of data augmentation. I take the MS COCO data set and generate new data. These generated data are stored in motion blur image dataset and Gaussian blur image dataset. Yolo V7 trained these two datasets and generate motion blur weight and blur weight. Let's see the result. In the video, it's hard to compare these three weights, but I found custom weights show better performance in extreme conditions. For testing custom weight, I prepared a test dataset with Gaussian blur image and motion blur images. Here is the result. When I test Yolo V7 and motion blur rate show 62% higher MAP value than Yolo V7. Blur rate offer an 80% higher MAP value than Yolo V7. I could find significant improvement in motion blur rate. Also, blur rate offer an 80% higher MAP value. But in standard images, the Yolo algorithm show better performance than my custom dataset. As a conclusion of this research, real-time object detection model need to judge whether each frame is disrupted and use optimized data to detect object on data. Thank you for listening.